Okay, if you can grab your sheet, and what I will do is go through, I guess, lesson one of our next unit, which is called exponential and logarithmic functions. A quick review of exponents, which you've seen since grade 9. If I look simply at this x to the power of the n, we call x the base, the exponent is n, and the entire entity itself is called a power. You can fill in these notes as you go. The product rule is x to the m times x to the n. Well, the product rule says we take the exponents and we add them if you have the same base. The quotient rule is if you take the exponents with the same base and you divide them, you subtract the exponents. Power of a power is if you have a power to another exponent, what we do is we times them together. So it'd be x to the power of m times n. And the power of a product, if you have a power that has exactly that to a product, it's x to the m times y to the m. And power of a quotient is x to the m divided by y to the m. So if you have a power to a fraction, it goes to both the numerator and the denominator. Fraction rule or an exponent rule that you might have forgotten since grade 9 is x to the power of negative m. Well, x to the power of negative m is really 1 over x to the power of positive m. Now that's going to come crucial later in this lesson, so you might want to put a star next to that one. As well as rational exponents. X to the power of m divided by n is really the nth root of x to the power of m. Or we could write it as the nth root of x all to the power of m. Okay, so we'll take the first example and we will learn how to rewrite these as positive exponents and without the use of brackets. So simply y to the negative 6. Well, that has a negative exponent. So that simply goes as we use the integral exponent rule. It has a negative exponent. We find it goes to the bottom, or the denominator, with a positive exponent. So y to the negative 6 goes to the bottom with y to the positive 6. B, 5x to the negative 3 and y to the negative 2. You can see x has a negative exponent, so it's going to drop down to the denominator of x to the power of positive 3. And then y to the negative 2 actually is you take and you flip it up. You move it over the fraction line and it becomes y to the positive 2. So a negative exponent we can see now is it actually moves it across the fraction line and changes the sign. You'll notice 5 stays exactly where he is, for 5 does not have the negative 3 going to it. What happens when we multiply? Well, we simply multiply the coefficients together. 4 times 2 is 8. X cubed times x to the negative 4, well, that uses our power rule or product rule, so we add the exponents. 3 minus 4 is going to be 3 plus negative 4 is going to be negative 1. And then y times y squared, well, that'd be 1 plus 2 is equal to 3. And so we have 8x to the negative 1 y cubed. But we have a problem. X has a negative exponent. So the negative 1 drops down. So we have 8y cubed over x. All right, let's look at D. D is now a dividing question. So simply we divide the coefficients. 24 divided by negative 4 is negative 6. M to the 5 divided by m to the 4, well, we go what is 5 minus 4? That gives us 1. P's, we subtract negative 3 minus 2. They would give us negative 5. And 4 minus negative 2. Now, here's a trick. We are subtracting a negative number. So 4 minus negative 2 is really the same as 4 plus 2, which is 6. So we end up with negative 6 mp to the power of negative 5 q to the power of 6. The negative 5 drops down and we get a positive exponent. And of course 24 divided by negative 4 is negative 6. So we'll have a negative 6 m had a positive exponent, it stays q6 p to the 5. Okay, E. We have 3x squared y cubed all cubed. As we saw the power of the product, the cube is going to go to every single part inside the brackets. So first we go, what is 3 cubed? And 3 cubed will end up being 27. The next thing is we say x squared cubed. If you look at your power of a product, or power of a power, sorry, you times them. So what is 2 times 3? Well, that is 6. And then y cubed cubed will be what's 3 times 3 is 9. So we end up with 27 x to the power of 6, y to the power of 9. And lastly, F. 12b to the negative 1/2 divided by 3b to the power of 1. So first off, we go, what's 12 divided by 3? Well, that is 4. And then we have negative 1 half, minus 1. Well, negative a half minus 1 is, we've seen already in trigonometry, as we involve fractions, we really have negative 3 over 2. Now the negative tells me it goes in the denominator with a positive exponent. So we end up with 4 over b to the power of 3 over 2. Please feel free to pause and let students write all this down. Okay, example 2. We are going to evaluate these without our calculator. So first off, we have 9 to the negative 3. Well, that might be tough to think mentally, so first what we'll do is get rid of the negative exponent. The negative exponent tells me it goes across the fraction line to a positive number, so now we have 9 cubed. And 9 cubed is really 9 times 9 times 9, which is 729. Okay, B, 81 to the 3 over 4. This is our integral exponent. The bottom number tells me which root we're taking, and the top number tells me which exponent are we taking. So we're going to do the 4th root of 81 cubed. Now the 4th root means what number do I times by itself 4 times to get 81? Well, that is 3. So the 4th root of 81 is simply 3. We still have a cube, so we now go, what is 3 cubed? And we get 27. 25 to the power of 0. Well, this is quite simple. Anything to the power of 0 is strictly 1. Okay, 16 to the power of negative 1 half. Well, the negative exponent tells me to go drop it in the bottom. So now I have 1 over 16 to the power of a half. And then power of the half goes back to question B. Instead of taking the 4th root now, because 4 was in the denominator, 2 is in the denominator. So I'm going to take the square root, or the 2nd root of 16. And 16 to the power, the square root of 16 is simply 4. My numerator of my fraction is 1, so I would have 4 to the power of 1, or just simply 4. So it ends up being 1/4. Okay, say we have to simplify p to the negative 1 q squared over 4p squared r squared, where p is 2, q is 3, and r is 5. Simply here is, first off, I would rearrange this to make it simpler. I have p to the negative 1 divided by p squared. Well, that's going to be negative 1 minus 2 gives me negative 3. I don't see q's anywhere, and I don't see r's anywhere, so I leave them as they are. But p to the negative 3 has a negative exponent, so I'm going to bring it across the fraction line and make it a positive 3. And now I simply substitute in. P is 2, so I'll end up with 2 cubed in the bottom. R is negative 5, so negative 5 squared. And q is in the numerator, so that's 3, so 3 squared. 3 squared is 9. 2 cubed is 8. And negative 5 squared is negative 5 times negative 5, which is positive 25. So now I have 4 times 8 times 25 is 800, and my numerator stays as 9, so 9 over 800. Okay, let's try class example number 4 now. Simplify, and what I'd like you to do is, so 4 times x times y to the negative 2 times all to the power of negative 3. Well, the negative 3 would go to the 4, the negative 3 would go to the x, and the negative 3 goes to the y. So we end up 4 to the power of negative 3, x to the power of negative 3, and now I have y to the negative 2 to the negative 3, and as we've seen, we multiply the powers together. Negative 2 times negative 3 is 6. Now 4 to the negative 3 means the negative tells me it goes across the fraction line with a positive exponent, so 4 to the power of positive 3, and 4 cubed is simply 64. X to the negative 3 tells me it goes across the fraction line, and so I have a positive 3, and y to the positive 6 simply stays. Okay, let's try this one. A negative a to the 5, b to the negative 3 all squared, b to the negative 1, and a to the power of 4 squared. First what I'll do is deal with these fractions, the brackets. So I have b to the negative 3 squared. I will multiply the negative 3 times 2, and I will get negative 6. In the denominator, I'll go 4 times 2, and I get a to the 8. So now I have a to the power of 5 over a to the power of 8. I will subtract the exponents. 5 minus 8 gives me a to the negative 3. I will now subtract the exponents on b. Negative 6 minus negative 1 is the same as negative 6 plus 1, which gives me negative 5. You can still see the negative out front of the a has remained all along. Now, a to the negative 3 and b to the negative 5, they both have negative exponents, which tells me they are both going to go over the fraction line. And now with both with positive exponents, so negative 1 over a cubed b to the 5. Question C. 3x cubed divided by 4y to the negative 2, all to the power of negative 2. The first thing, let's work on the outside and work inwards. So the negative on the 2 tells me that both of these things are going to flip. The top will come across the fraction line and the bottom will come up across the fraction line. And now the 2 will become positive. So the denominator is now my new numerator and the numerator is now my new denominator. And now the squared goes to everything inside. 4 squared is 16. Y to the negative 2 to the power of 2 as we times. Negative 2 times 2 is negative 4. 3 squared is 9. And x cubed squared, well, 3 times 2 is 6. And now, simply, we say, well, y to the negative 4 means it's going to go across the fraction line to the bottom with a positive exponent. D. Hope you're having fun. All right, now what we'll do is we'll look at negative 8x to the power of 8 y to the power of 5 over 25x squared y. Well, you can read the rest. So first what I'll do here is I will simplify. Sorry, let me go back. This one I dealt with the fractions outside and worked inward. And this one what I do is I'll work inward and then go outward. So, and you'll see you get the same answer. So looking at this first fraction, negative 8 over 25 cannot be simplified. X to the 8 divided by x squared, well, I simply go 8 minus 2 is x to the power of 6. Y to the power of 5 divided by y, well, that's 5 minus 1 is simply y to the 4. Now this fraction, 5 over negative 4 cannot be simplified. X cubed divided by x, well, that's 3 minus 1 will give me x squared. And y to the 9 divided by y to the 5, that's 9 minus 5 is 4. Now we have to deal with the squared. The squared will square everything. 5 squared is 25. Negative 4 squared is positive 16. X squared squared, well, 2 times 2 is 4. And y to the power of 4 squared is y to the power of 8, since 4 times 2 is 8. Now we've seen this before, multiplying fractions. Well, we multiply straight across. What you can see is there's a 25 in both the numerator and the denominator, so they will cancel. Negative 8 over 16 is left, which is also more commonly known as negative 1/2. X to the power of 6 times x to the power of 4, we add the exponents now. 6 plus 4 is 10. And y to the power of 4 times y to the power of 8 is 4 plus 8 is 12. Please pause and look over the work. Okay, we now have the last example. We're going to convert these to a new base. So 9 to the power of 2x, we're going to convert to base 3. How to do that is simply, instead of writing 9, I'm going to write 9 a funny way. I'm going to write it using base 3. So instead of writing 9, I will write simply 3 squared. As you can tell, 3 squared is the same as 9. But now you see I have 3 squared to the power of 2x. What happens when you have a power of a power is you multiply. 2 times 2x is 4x. 125 to the 2 minus x to base 5. Again, I'm going to write 125 as a different way. I'm going to write 125 simply as 5 cubed. Now 5 cubed is 125. But again, now I have a power to a power, so I'm going to multiply 3 in. 3 times 2 is 6, and 3 times negative x is negative 3x. Part C, we have 8 times 16 to the x. We're going to write this in base 2. So now, instead of writing 8, I will simply write 2 cubed. And instead of writing 16, I will write 2 to the power of 4. Now notice the x still stay outside. Again, I have a power to a power, so I've times them. 4 times x is 4x. Now I have powers that are being multiplied together. When using the rule, we add the exponents, so 3 plus 4x. And we end up with 2 to the power of 3 plus 4x. Say I want to write 1 over 512 to the 3x to base 2. Well, first off I write, well, 512 is simply 2 to the power of 9. So 2 to the power of 9 is 512. Now I have a power to a power,